We are talking about exponential growth and decay functions, and we want to write equations for exponential functions. So here we have a table in example 3, and we want to write an equation y equals ab to the x. So the first thing we need to do is identify the y-intercept. The y value is our a value. So in this case, we have our y-intercept is where the x value is 0. So that's our y-intercept. So in this case, a is equal to 1. And the next thing says, then plug any point xy in, so any point we want. And I'm going to pick the easiest exponent to deal with, which in this case is going to be x is 1. So we get an xy coordinate, and we're going to pick 1, 5. So we can substitute those into the equation. So our equation that we're working with, again, is y equals ab raised to the x power. So our y value in this case is going to be 5. Our a value is 1. We don't know what the b value is. That's what we're trying to calculate. And our x value is going to be 1. So it's nice if we pick values that are real easy to work with, because this one basically solves itself without really doing any work. We can bring down the 5. B to the first power is just b, and b times 1 is just b. So b is equal to 5. So all we have to do is substitute that into our equation. So y and x are going to stay y and x. Our a value we said was 1. And our b value we calculated was 5. And we're still going to have raised to the x power. So 1 doesn't affect it at all, so we can simplify this a little further, and we get y equals 5 raised to the x power. Another example that we have is over here on the right, and the same thing. We want to calculate or find our y-intercept. So our y-intercept in this case is where the x value is 0. So our y-intercept is our a value. So a is equal to 1. And we can pick any value we want to substitute in. And in this case, we want to pick one with an easy exponent. So we should know a lot of the values that would go with or be able to calculate a square root pretty easily. And we can substitute those values in. So that tells us that we're getting an xy of 2 and 1/16. So we can substitute those values into the equation. Y equals ab to the x. We know that our y value is going to be 1/16. And we know that our a value was and our b value we're trying to calculate, and our x value is 2. So we can go and we want to solve to get b by itself. So we're going to use GEMDAs. And we start with addition and subtraction and work our way to groups. In this case, we don't have any addition and subtraction. And we actually don't have any multiplication or division either, because 1 times b squared is just b squared. So I can rewrite that as 1/16 is equal to b squared. So now we have an exponent there that we need to get rid of. And so we can take the square root of both sides. And something that we need to just remember is if we're taking the square root here, another way to write that is we can write that as the square root of 1 over 16 is the same thing as saying the square root of 1 over the square root of 16. Well, the square root of 1 is 1, and the square root of 16 is 4. So this right here can reduce to 1/4. So we get 1/4 is equal to b, and then we can substitute those values back into the equation. And the y value is going to stay y. The a value is 1, so that's not even going to affect the equation, so we can just leave that one off. And then we calculated the b value as 1/4. And we got to put that in parentheses because we want, when we raise it to the x power, we need to make sure that all parts of that are raised to the x power. And so that is our final solution for this one.